205, 207, 209. And so, really, these are page 846, right? Okay. So that's going to punch up in just 1 second. I think I will start with 203 then. That's the first one we asked. It says the sine of x is negative 0.721. Okay? And the directions tell me solve the equation and then approximate the solutions which lie in the intervals 0 to 2 pi. Okay? Find solutions. I feel like I did this one in class. No? Find these solutions in the interval 0 to pi. I mean, Justin, you told me, you said, I'm not particularly attached to problem 203. I just want to learn how to understand how to do these problems.
Right.
203 is harder in a way because I had to pull out the calculator in order to figure out what x was. Okay? But there are other problems in this homework that I think if I do one, it could be helpful. So I'm going to do that. I'm going to say that if you want to look at 203, you can look at the notes from last week. You can look at the video again. But I guess in lieu of this, let me pick another problem. And I want to go to the homework you've been working on. That'd be smart. Let's try 188 as an example. It's on the previous page. And I'll again try and make it a step-by-step as a suggestion. So sine of x, it says, is 7 over 11. I think sometimes that's useful. And it says what we're trying to do again is find all the solutions in the interval 0 to 2 pi. Now, I want to draw a picture, which is my usual process. And you'll notice that 188 is different than 203. It's one of the reasons I picked it. I mean, they're both sine, but one of the things that's different is that it's positive. So it's not going to have an answer down in quadrant 4. Remember, 203 had answers in quadrants 3 and 4. And I said, well, someone asked me just now, how do you know? Well, because the signs are negative there. Here the sign is positive 7 over 11. Does that make sense? So I claim one of the places we're going to find answers is in quadrant 1. Because quadrant 1 is a place where sine, cosine, and tangent are all positive. And so I want to go ahead and draw my angle like this. And I'm going to drop this perpendicular so that I'm getting a right triangle. And I'm going to say that x is the measure of perhaps of that angle. X, that angle in there could be my x. It's funny because usually we've been using a Greek letter for an angle, but this is just using x. And I guess I should label some things. If it's 7 over 11, what should I label? Opposite is 7, hypotenuse is 11. You guys with me so far? Now, could I figure out that third side if I want to? Sure, I could. Okay. And maybe we will. We'll see. But now the question is there anywhere else that the sign would be 7 over 11? Well, I claim you could also have a similar thing happen in quadrant 2. And so I guess I need a different color marker. Imagine that my angle went all the way over here so that, again, I had a 7 there and an 11 here. Does it make sense to you guys that the blue angle would work and the black angle would work. You guys follow that? Now, I'm about to use my calculator here, and I want to show you guys something. The calculator has a function that will help me find one of these answers. Okay? And the one it'll help me find, x could be, if I type in the inverse sine of 7 over 11, that'll give me one of the answers, right? Inverse sine of 7/11. But which answer will that give me? The one in quadrant 1 or the one in quadrant 2? Quadrant 1. Because why? Because we said that the range of inverse sine of x, or inverse sine of x, is from negative pi over 2 to pi over 2. And so it's not going to give me the quadrant 2 answer, only going to give me the quadrant 1 answer. Go ahead, Molly, question?
So if the range is negative pi over 2 to pi over 2,
Yeah.
is the angle in quadrant 2 even an option?
Well, I won't get it. If it said arc sine, then no. Arc sine is not an option. But see, this problem doesn't say find the arc sine. This problem says find solutions to this equation, kind of like we did here for 203. I'm telling you that one of those answers will be this. This is one solution. But I'm telling you there's actually going to be infinitely many solutions. So let me start to write them down. Let's see. Let me check what mode we're in, first of all. Oh, I'm in degree mode. I don't want to be. Let's go to radian mode so that we match what the book has. So I'm in radian mode. And now I'll type in inverse sine of 7/11. Enter. Okay. So I got 0.689 if I round 8. 0.6898. Tyler, question?
Why are you taking the inverse function and the arc sine instead of just the regular sine?
Well, it doesn't say sine of 7/11. It says sine of some angle x equals 7/11, right? I want to find the solution. I want to find x. So what they're asking me to do here is find an angle. Does that make sense? Okay. So it's kind of like, how do you get to that x? You take the inverse sine is one way of thinking of it. Does that make sense?
Yeah.
Inverse sine is what you do when you want to find angles. And that's what I'm looking for. Go ahead.
So the reason why it only gives you the first answer is because of the range, right?
Yeah.
Okay.
And functions can only give one answer, right? That's the key about a function, is it only has a single output. But if I want another answer, how about I do 0.6898 plus 2 pi? Let me draw that answer. That'd be like if you went 0.6898 and then kept going, another 2 pi, right? Wouldn't that red angle have the exact same values for the trig functions that the blue angle has? Yeah, they're coterminal angles. Let me figure out what that angle would be. So I can take my answer and I can add 2 pi to it. Let's see. So I'll say 2 pi. Enter. So there's another answer, 6.97. But you know, it's going to be kind of dumb if I'm going to sit here and start listing every answer I can think of, right? I'll just be spinning my wheels literally. So instead what I do, if I say, can I list all possible answers? That's the question. So again, arcsine helps me find one of them, and then I use that to find the rest of them. So I guess I could say 0.6898 plus 2 pi k. That'll give me all the answers that appear in which quadrant? Quadrant 1. Now, are there other answers? There are. I haven't found them yet. Right? Although I drew one of them, I drew the black one. So now the question is, how the heck do I find the black angle? Let me do it. And again, this is the steps. First, I find the one that's easy, the quadrant 1 angle. I know there's going to be another one. Kind of like in the last problem, I found the quadrant 4 angle, which was in the range, and I know there's another one. Is this okay? So how do I find that? Well, I guess here's where the picture really helps. I know that if I were to rotate this far, how many radians is that? That's pi, but that's too far. But I use that to my advantage because now I say, okay, how do I get the angle I want? See if this makes sense to you. What if I told you what we have to do is pi minus the blue angle? Minus, what is the blue angle? The inverse sine of 7/11. Does that make sense? Who follows what I'm saying here? Okay, so another answer then, and this is a quadrant 2 answer, is 2.45 radians. How did I get 2.45? I did 3.14 minus 7/11, right? I did pi minus 7/11. And then I may as well put plus 2 pi k because if I were to start spinning my wheels in the second quadrant, I'll get all the possible answers. So there's all the possible answers for problem 188. Question, go ahead.
So could we write it as like, even though this is, I don't know if this would be good, but instead of doing the 2.4, could you just do pi minus
Sure.
6.89 for the answer? So would that be an acceptable answer?
Sure. So you're saying instead, let's write it as pi minus 0.6898 plus 2 pi k. Yeah, that makes sense to me.
I don't know, that's what I think.
Sure. Sure.
So if it were in like quadrant 2 and 4, what would you subtract?
We did that. Let me take a look at one.
Right.
Let's look back at that problem. When we did number 203, which is what you guys first asked about, okay, it says one of them answers was, again, the inverse sine. And so that was the black one. And so I guess to get the red angle, didn't I do... What I did was, I noticed that from here to here was pi, but what I did was pi plus what I got the first time. The inverse sine of negative 0.721. So that's interesting, because in the problem I just showed you, it was pi minus, because I had to not rotate as far as pi. But to get this red angle, I had to go a little farther than pi to get that red angle. So, you know, I wish I had a magic formula that it's always plus or always minus, but I don't. What I have is a process, which is that I'm going to draw the picture, and I'm going to understand that I can get one of the angles using the inverse trig function, and then I'm going to have to do some reasoning, as I explained, in order to tell you how to get the next angle. Okay? Yeah, I'm really glad you guys asked me to go through this a little more slowly. So 10.7 is on trig equations, well, and inequalities. We're not going to do any inequalities today. I'll do some next time. I think equations is enough. You might remember from algebra class, solving inequalities is a lot like solving equations anyways. So I think we'll be okay here. But let me go ahead and start with, well, how about I start with problem 2 as an example. They give me the cosine of 3x is equal to 1/2. Okay. And by the way, one thing that I think can help for these problems is to remember that what goes in here is an angle, right? So here, let me rewrite the problem as cosine of theta equals 1/2. Okay? And I guess my first thing I'm going to have you guys do is try to find as many solutions as you can. How many solutions are there? Right? To the red problem, there are infinitely many solutions. So I'd like you to find, how about I say, all values of theta that work. And I'd like you to work with someone next to you for a little bit. I'll walk around and see how that goes, because it really does tie into what we just did. This is a cosine problem instead of a sine. Let me show you guys some of the things people did. I had people write this down. Theta equals inverse cosine of 1/2. And by the way, that's just one answer, right? One answer is the inverse cosine of a... By the way, do you guys know the range of the inverse cosine?
0 to pi.
0 to pi. We're going to want to know that for Wednesday, aren't we? So the inverse cosine function has a range between 0 and pi, and that means that, well, we're in quadrant 1 or 2, right? And I had a lot of people draw a picture of this, and they said, okay, let me find which quadrant I'm in. By the way, this inverse cosine, since the cosine is positive 1/2, does it make sense to you that where my solutions would be, it would be in quadrants 1 or 4? Here. One of the reasons I picked this one is because, yeah, we're very familiar with this, right? Where do we have a cosine of theta equals 1/2? Give me a theta that works. You could see it, right? Pi over 3. There's another answer. What's another answer? Down here, 5 pi over 3. Okay? So this particular problem works with the unit circle. But see, the problems that I assigned on the homework, the unit circle wasn't very helpful. You had to draw your own picture and you had to use the calculator. So here, let me try it again with the calculator. Suppose I typed in, here we go, inverse cosine of 1/2. Guess I could have typed 0.5, would have saved time. There it is, right? 1.04 what? Yeah, is that the right answer? Well, maybe it is, right? Here, if I divide out the pi, this is kind of interesting. What do you think I'm going to get? I get 1/3. Remember we said the answer was pi over 3? Okay, so one answer is theta equals pi over 3. But that's not all the answers. So where's that answer take me? That would be right here, right? That's one value of theta that works. Now, how do I get another answer? Well, you guys told me that another answer I would get down here. Because I can see, again, that the x-coordinate of each of these is 1/2. This one, the y-coordinate, is negative. But I can see that the x-coordinate is 1/2. Now, what angle would this be? Well, what if I told you that theta is negative pi over 3 as an answer? Would that make sense to you guys? But see, when I say find all values of theta that work, what else do I have to do now? I have to start adding multiples of 2 pi. You guys with me so far? So what if I said that the answer would be things like this? Theta could be pi over 3, pi over 3 plus or minus 2 pi, pi over 3 plus or minus 4 pi, dot, dot, dot. That's one way to write the some of the answers. And then also, I have to remember that there's other answers, because we had negative pi over 3. We have negative pi over 3 plus 2 pi, well, plus or minus. We have negative pi over 3 plus or minus 4 pi. Okay? And actually, one of the things I want to say is, I still never wrote down 5 pi over 3. Or did I? Is 5 pi over 3 in this list right here that I have in the rectangle? Where? I guess if I took the negative pi over 3 and added, how am I going to rewrite 2 pi? 6 pi over 3, that gives me the 5 pi over 3 that you guys mentioned. Okay? So it really is there in this list. This is really what I'm doing. You guys with me so far? Okay. That's the questions you guys asked me about, and I noticed it's in problem 2 of the next section. But I'm not done, because the directions for the next section don't say solve for theta. They actually say solve for x. Solve for x. Find the values of x such that the cosine of 3x is equal to 1/2. So yeah, what did we learn so far? Whew. Let me zoom out a little bit so you could see what's going on here. I need to rewrite the directions for problem 2. Problem 2 says, find all exact values of x that are solutions, and then list all x between 0 and 2 pi that work. Okay. So this is kind of interesting. We got some different values for theta that work. But I don't want theta, I want 3x. I want to know what x is. See, for example, the very first thing I found was theta equals pi over 3. That was the first answer I found. Well, that means that 3 times x is pi over 3. And so what does that mean? X is equal to what? We have to divide by 3, that's right, on both sides.
Pi over 9.
So we're going to get, does that make sense to people? Pi over 9? Because dividing by 3 is the same as multiplying by 1/3, right? So we get pi over 9. Another answer we had was that theta is 5 pi over 3. But that means 3x is 5 pi over 3. And so what does x equal? Help me out. 5 pi over 9, thank you. So there's an answer. There's an answer. You guys with me? What if I told you there's more answers? I hope you're not going to get too annoyed. Here. Let me go to the calculator and show you exactly what we're doing here. So the calculator, we're doing this, guys. If you go to the y equals screen, I'd like to just graph for a minute cosine of x, and I'm going to hit zoom trig just to remind you what the heck's going on here. You guys are good with that, right? That was from the exam 1. Find the cosine function. Now I'm about to graph something. Instead of graphing cosine of x, I'm about to graph 3x. And before I press the graph button, can you tell me what we're going to change about that graph? Let me pause for a minute while you talk to someone near you about what that's going to change. Okay, this is going to make the period shorter. So when I graph it, I think that should make some sense to you, right? Now, this is the graph of y equals cosine of 3x. What I'm trying to do is figure out, when is it true that cosine of 3x is equal to a half? And let me graph y equals a half. Of course, that's a horizontal line, right? Now, again, pay attention here. When I graph cosine of x, and I say, where does that meet y equals 1/2? Well, if I'm just looking between 0 and 2 pi, there are two places, right? Here and there. But if I change and say I'm not graphing x anymore, I'm graphing 3x, does it make sense to you that there's going to be more solutions in the interval 0, 2 pi? Because we've changed the wave and made it, we've kind of increased the frequency because we decreased the period. Do you guys see there's lots of places where the line hits the wave? And let me show you a few. If I hit second calculate a value, and if I type in pi over 9, pi divided by 9, well, we know what the output's going to be. It's going to be a half. And it shows me one of those places where it equals a half. Or if I were to do the same thing and type second calculate the value 5 pi over 9, again, it's going to be a half. But do you see that there are other answers? There's 5 pi over 9. How many other answers are there? Well, it looks to me like there's another one here, another one there, another one there. There's like 4 more answers to deal with. And so the question is, how do you find those? Okay. So again, a process. Let me help you a little bit. We're looking at these types of answers. Pi over 3, pi over 3 plus 2 pi, pi over 3 plus 4 pi. And we're also looking at negative pi over 3, negative pi over 3 plus 2 pi, negative pi over 3 plus 4 pi. Right? And notice, so far I've dealt with 2 answers. I did pi over 3, and I did negative pi over 3 plus 2 pi. Let me next do theta is pi over 3 plus 2 pi. So that's like, looking at the picture again, that's like the blue angle, pi over 3 plus another 2 pi. So theta here is 7 pi over 3. But remember what theta is. Theta is not theta in terms of x's. What is it? It's 3x is 7 pi over 3. So what does x equal? 7 pi over 9. Is that answer between 0 and 2 pi? 7 pi over 9. Actually, it's less than pi, right? And again, I can show you on the calculator. It might help. There's the graph. Right? Yeah, we're going... So if I take the value 7 pi over 9, that's not even pi yet. And I need all the values between 0 and 2 pi that give me a half. There's another one. So you could use the calculator like I am if you want. It can help you find the answers. Let's see, to get another one, let's try theta equals negative pi over 3, like I started with last time. This was plus 2 pi, so now I'll do negative pi over 3 plus what? 4 pi. Now let's rewrite it using x's. 3x is what we want to write. Negative pi over 3 plus, boy, how should I write the 4 pi? Why don't I write it as 12 pi over 3? Right? That's the same as 4 pi. So I get 3x is 11 pi over 3. And so another answer is going to be, help me out, 11 pi over 9. Now see, mathematics is the study of patterns, and so I really hope that maybe I can get the next few without all the work, seeing that it's 10:45. You'd have to add another 2 pi, do it again, another 2 pi until you get them all. But this is the process you would do. Okay? Nice work today. Guys, these new... Okay. So back to inverse trig. Last time we were here, we were just solving problem 2. And we were taking our sweet old time on this, okay? Because I wanted to make sure we understand. Let me give you a little refresher, okay? When I write the cosine of 3x is 1/2, I want to find all the values of x that'll solve this equation. And there's a lot. Even what I can do is replace the 3x with theta. And I understand that there's a lot of solutions to this equation. That's something we've been talking about lately. One of them is the arc cosine. And how do you get the other ones? Well, let's see. The arc cosine of 1/2 is in quadrant 1. But you understand there's also an answer in quadrant 4. And then you can add 2 pi to these answers. So I went through this last time, and we got a whole infinitely long list, right? I mean, we have ... going on here. These are all different values of what I'm calling theta. Now, theta took the place of what in my equation? 3x. So it's not really that theta equals all of these things. It's that 3x could be any of these things. So how do you get what x equals then? Well, you divide any of these things by 3. Okay? And that's what x could be. So there's a lot of solutions when it comes right down to it. And we started to list some of them, right? Because we knew that theta could be pi over 3. We knew that theta could be 5 pi over 3. How did I get that? Yeah, oh, actually, yeah, that was this one, right? It ended up being 7 pi over 3. We added 2 pi to it. But we also took negative pi over 3, the green ones, and we added things like 2 pi or 4 pi. So there were a lot of solutions. Okay? And I guess, to do this homework, what's he say? He says find all of them. Find all of the exact solutions. All right. Take a look at their answer. Okay. Well, yeah, there's a lot of them, right? Let's see. So we have pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, right? And he keeps going and found 2 more that we didn't find yet. But I also like the way that he writes this solution. X equals pi over 9 plus 2 pi k over 3, or 5 pi over 9 plus 2 pi k over 3. In other words, if I were doing this, I might try this. Theta is pi over 3, right? Or theta is negative pi over 3. Those were kind of what I would call the 2 families of solutions. One from quadrant 1 and one from quadrant 4. And then if I, by the way, which one is the arc sine? Well, I'm sorry, arc cosine is how we got it. Arc cosine is the one that gave me pi over 3. But then what you have to do is you have to say, well, I know that 3x equals pi over 3 is a solution, and I know that 3x equals negative pi over 3 is a solution. So x could be pi over 9, and x could be negative pi over 9. Does that make sense? So I guess the only other thing I'll say is that, you know, adding 2 pi k over 3 to these things is what happens. And I think you'll see why it's over 3 when I do this second example. Let's get to one. Let's do number 10. That's a nice problem. It's another cosine problem. It's one of the reasons I like it. So number 10 says, hey, the cosine of x plus 5 pi over 6 equals 0. All right? The cosine of this thing equals 0. We want to find all the values of x that will solve this equation. Now, one of them, before we do that, an easier problem would be this. Cosine of theta equals 0. Agree? We can just figure out what theta equals. How can the cosine possibly be equals 0? Oh, wait a minute. We can draw a picture of that, right? Here. Can you give me a theta so that the cosine will be 0? There's one. If theta is pi over 2, then on the unit circle I'm at 0, 1. So that's one answer, right? As a matter of fact, and of course I'm off the screen again, my gosh, having a bad day with that today. If I look on the calculator, what do you think it would give me if I happened to type in inverse cosine of 0? Do you know what it's going to spit out? Oh, it spit out 90, because what mode am I in? Did it again. But of course, 90 degrees is kind of nice, because we know that's the same as what?
Pi over 2.
Pi over 2. Does that make sense to people? And I should have known that. So this is, in fact, the inverse cosine of 0 equals pi over 2. I should have known that would happen, because what's the range of the inverse cosine? 0 to pi. It's quadrants 1 and 2. Okay? So these are good things to start learning. Now, are there other angles that have a cosine of 0? Think about the whole unit circle. Sure, there's another one. Another one would be this angle, which is 3 pi over 2. Let me give you another answer. Another answer would be going this way, which is negative pi over 2. Go ahead, Molly.
Because the range is 0 to pi, you wouldn't be able to use 3 pi over 2, right?
If I use my calculator, it'll never give me 3 pi over 2. It'll never give me negative pi over 2, right? The only answer I would possibly get from my calculator is what? Pi over 2. And you understand, these inverse trig functions will only give you one answer. But if you have a trig equation, which is the new subject for section 7, there are more than one answer. In fact, there's infinitely many answers. That's why this is a new section. You guys just took a quiz. Each one of those problems had how many answers? One answer. Except for the one that had no answers. But right? But now I'm saying solve the equation. Well, the equation's going to have infinitely many answers. So now we have to be a little more careful about how could we list all the answers. Well, theta, before I do this, Justin, go ahead. You had a question.
Well, I used
Okay. So if I want to list them all, why don't I say theta could be pi over 2 plus any 2 pi k you want to add. But then also theta could be, and what do we want to use, 3 pi over 2? Okay. Plus any 2 pi k you want to add.
Couldn't we put, it could be pi over 2 plus pi k, because if you go over 1 pi, then you're...
Oh, that's another way to do it. I'm just splitting it up into cases, but you're right. That's another way to do it. Molly?
I thought we couldn't use 3 pi over 2 because of the range.
You can't. I guess what I will say is this. The arc cosine of 0 does not equal 3 pi over 2. But it is true that the cosine of 3 pi over 2 equals 0. That's true. But you can't do the inverse cosine to get it. You can only get it from looking at the picture.
Oh, okay.
Okay? So, the last thing I'm going to say is, we're not solving for theta. What are we solving for? X. And what I have so far is that x plus 5 pi over 6 equals pi over 2 plus 2 pi k. Or I have x plus 5 pi over 6 is 3 pi over 2 plus 2 pi k. So how the heck am I going to get values of x that work? I'm going to do a little algebra. Guess what I'm going to do to both sides of the equation? Subtract what? 5 pi over 6. Now, you have to trust me on this because we're out of time. That if I do 9 pi over 6 minus 5 pi over 6, it's 4 pi over 6, which is 2 pi over 3. And then the same thing here, you could get it. But there, for example, are some of the answers. We'll talk more about this on Monday. But this should be at least enough to get you working on the first homework for the trig equations.
Number 7 and